Hey everyone, here it's chapter 4, Refraction of Light. Refraction of light is change in direction of the path of light when it passes from one transparent medium to another transparent medium. Next slide, refraction index. Mu is equal to sin I upon sin R is equal to speed of light in medium 1 upon speed of light in medium 2. Snell's law. Prism, a transparent refracting medium bounded by 5 surfaces inclined at the same angle. Angle of deviation. Delta is equal to I1 plus I2 minus R1 plus R2. Relation between angle of refraction and prism. R1 plus R2 is equal to A. Relation of angle of incidence and angle of prism. I1 plus I2 is equal to A plus delta. Angle of minimum deviation. Delta minimum is equal to 2I minus A. Shift due refraction. Shift is equal to real depth into 1 minus 1 upon A mu m. Apparent depth of an object due to refraction. A mu m is equal to OA upon IA is equal to real depth upon apparent depth. Apparent depth is equal to real depth upon A mu m. Critical angle. A mu g is equal to 1 upon sin c is equal to cos x c. Case 1. When the angle of incidence is small, I is less than c. A light ray AOA, therefore, the angle of refraction R is greater than the angle of incidence I. Now, if the angle of incidence I is gradually increased, the angle of refraction R also increases, but the intensity of refracted ray keeps decreasing. Finally, the angle of refraction R reaches its maximum value equal to 90 degree at a certain angle of incidence I is equal to C. Here, C is called the critical angle. Case 2. When the angle of incidence is equal to the critical angle, I is equal to C. At angle of incidence equal to the critical angle, I is equal to C, the angle of refraction becomes 90 degree as shown. The refracted ray is along the glass-air interface and is very weak. Case 3. When the angle of incidence is greater than the critical angle, I is greater than C, the incident ray AO at an angle of incidence I greater than the critical angle C, no refracted ray is obtained and the incident ray totally reflected as OC.